Hello everyone. In this video, we will see the continuation of the third chapter, Playing with Numbers, exercise 3.3. So the first question of exercise 3.3 is, using divisibility test, determine which of the following numbers are divisible by 2, 3, 4, 5, 6, 8, 9, 10 and 11. Just have to write yes or no like that. So we have to check it with divisibility rule of each and every number. So the first is already being done by in the question itself. Second is the 990. Yes, it is divisible by 2. It is also divisible by 3 because the sum is the divisible by 3. Coming to the 90, is 90 divisible by 4? No, because we see for the 4 last two digits. Then 5, yes, because it has 0 in it. Then with 6, yes, because it is divisible by 2 and 3. So it will be divisible by 6 as well. For 8, it will be no because the last three digits, which is 990 only, is not divisible by 8. For 9, it will be yes because it will be 110. For 10, yes because it has 0 in it. And for 11, yes because when we add 9 plus 0 minus 9 is coming as 0 or the multiple of 11. Coming to this, let's just fill it. Yes, then no. Okay, let's see first of all by all the 2. It will be not. All the even numbers will be divisible by 2. Yes, 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 and no. Coming to 3, the sum should be divisible by 3. So it will be no in this. Then it will be no. Then yes, because sum is coming out to be divisible by 3. Then yes. It is also yes. It is also yes. And it is also yes. Just add all these and see whether it is multiple of 3 or not. Coming for the fourth is you will be, it is not because 86 is not divisible by 4. Then 75 is also not divisible by 4. 86 is also not divisible by 4. 10 is also not divisible by 4. 14 is also not divisible by 4. 56 is divisible by 4. 60 is divisible by 4. 39 is not divisible by 4. Coming to 5, we should have 5 or 0 at the end. So yes, no, yes, no, no, yes, and no. Coming to the 6, whatever numbers are being divisible by both of 2 and 3, you can write yes in that. So it is no because it is not divisible by 3. Again no. Again no. Yes because it is divisible by both 2 and 3. Yes. Yes. Yes and no because it is not divisible by 2. Coming to the 8th. In 8 we see the last 3 digits. So for the 8th it will be no because it is not. Then again no. Again no. Again no. 714 is not divisible by 8. If I say 856 is divisible by 8, 60 is not, and 839 is not. Coming to the 9, for 9 we will have the sum is divisible by 9 or not, so it will be no. We have to just add all the numbers and see whether it is divisible by 9 or not. So no, it is yes, it is no, it is yes, and it is no. Then coming to the 10, the number should be at the end, units it should be 0. So no, it is clearly visible. No, no, yes, no, no, yes, and no. Coming to 11, the difference of even, sum of even and sum of odd place digit should be 0 or multiple of 11. So it first is already given no, second is yes, third will be no, then it will be yes, no, yes, it is no, 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 and no. Okay, so this is how you will fill this table. Coming to the next question of exercise 3.3, which is saying, using divisibility test, determine which of the following numbers are divisible by 4 and by 8. Okay, so let's say 574. For divisibility rule, of 4, I'm doing the first one, divisibility by 4. We'll check last two digits, which is 72 is divisible or not. Is divisible or not. So is 72 divisible by 4? Yes, tell me. Just think about 2. So 72 is divisible by 4. Yes, so it is 572 is divisible by 4. And is 572, the last three digits, is divisible by 8? No. The last three digits, if I say divisibility by 8, 572, you can write last three digits should be divisible by 8. Should be multiple of 8 or divisible by 8. But in this, 572 is not divisible by 8. This is the number only. If I say the B part, for the B part, we have the last two digits as 52. So I am writing here, bache, is it divisible by 4 or not? If we see the 52, 52 is divisible by 4, hence it is divisible by 4. It is divisible by 4. And if I say the last three digits, 352 for the 8, it is, yes, 352 is also divisible by 8. So it is divisible by 4 and 8 both. If I say 5500, it has 0, 0 at the end. So when we have 0, 0 at the end, that means it is divisible by 4. Any 0 is divisible by everything, yeah, right? So 0 is, it is divisible by 4. But 500 is not divisible by 8, but not 8. Coming to the D part, we have 0, 0. So yes, divisible by 4. And 8 also, because it has 3 zeros in it. So it is divisible by 8 as well. If I say 59, not divisible by 4. Not divisible by 4. But if I see for the 8, 159. For 8, we see the last three digits and also not 4. Not by 8 as well. If I say 60, yes, it is divisible by 4. 60 is divisible by 4. And if I say 560, because at the end it is 560 for the 8 digits, and 560 is also divisible by 8. If I say 84, yes, it is divisible by 4. And is it divisible? 084. Last three digits are 084. So is 084 divisible by 8 or not? No, it is not. Sorry, not divisible by 8. 72, is 72 divisible by 4? Yes, 72 is divisible by 4. And is 072 divisible by 4? That means 72 only. Is it divisible by 8? Yes. Last two digits divisible by 8 as well. If I say 00, it is divisible by 4. But if I say 700, is 700 divisible by 8? No, not divisible by 8. So you do not need to divide whole number. Just check for the last two or last three digits. In this, we have 50. Is 50 divisible by 4? No, not divisible by 4. And is 150 divisible by 8? No, so not divisible by 8 as well. And this is how you will write all the parts. I have done A part for this. Coming to the third, using divisibility test, you have to check which of the following are divisible by 6. Now for the divisibility rule of 6, what we have to do, just write the divisibility rule of 6 is that numbers should be divisible, both numbers should be divisible by both 2 and 3. That means now you will write divisibility rule of 2 is number should be even. Just simple. number should be even. And divisibility rule of 3 is sum of digits should be multiple 3 or multiple of 3. Okay, so let's do the first A part. For A part, it is 297144. It is divisible by 2. It is even number. So yes, it is divisible by 2. Let's check for divisible by 3 or not. 2 plus 9 plus 7 plus 1 plus 4 plus 4. It is giving us the sum as 27. So yes, we can further do it. 2 plus 7, which is 9. So yes, it is divisible by 3. So that means 297144 is divisible by 6 because it is divisible by both. So you can just write yes here. Coming to 1258, just check. Yes, it is even, so it is divisible by 2. But for the 3, you have to check for the sum. 1 plus 2 is 3 plus 5 is 8 plus 8 is 16, which is not divisible by 3, right? So it is not divisible by 6. If I say it is not only the prime even number, so you can just write the no. It is also not the even number, not divisible by 2, so directly write 2. No. It is a even number, so it is divisible by 2. You have to check for divisibility by 3. So it will be 9 plus 1, 10 plus 3, 13 plus 5, 18 plus 2, 20. So 20 is not divisible by 3, so it is not divisible by 3, so it is not divisible by 6. Now again, it is also even number, so you have to now check for the divisibility rule of 3. 4 plus 3 is 7 plus 8 is 15 plus 5, 20 and 27. So yes. It is also even number. Check for the sum. The sum is coming out to be 1 plus 7, 8 plus 9, 17, 18, 18 plus 4, 22 plus 8, 30. So yes, number is divisible by 3 and also by 6. It is not a prime even number, so you can directly write no. It is an even number. Check for the divisibility rule of 3. Yes, the sum is divisible by 3, so it is divisible by 6 also. For this also check for the 3 because it is even number, but it is sum is coming out to be 8 plus 8, 16 plus 5, 21 and 23, which is not divisible by 3. So it is not divisible by 6. Coming to question number 4. Using divisibility test, determine which of the following are numbers are divisible by 11 now. Now for 11, you have to check 5, 4, 4, 5. For 11, what you have to do, you have to add the odd number places like 5 plus 4 and then subtract the even number places like 5 plus 4. It is coming out to be 9 minus 9, 0. So yes, it is divisible by 11. Coming out to be 10824. Add the odd number places like 1 plus 8 plus 4 and then minus the sum of even number places 0 and 2. It will be 0 plus 2. So it is coming out to be 9 plus 4, 13 minus 2, which is 11. So yes, it is also divisible by 11. For 7, 1, 3, 8, 9, 6, 5, add all the even and odd. So it will be 7 plus 3 plus 9 plus 5 minus 1 plus 8 plus 6, which is coming out to be 10, 19 plus 5, 24 minus 9 plus 6, 15, 9. So not divisible by 11. You have to just check like this. So 70169308. It will be 7 plus 1 plus 9 plus 0 minus 0 plus 6 plus 3 plus 8, which will be 8 plus 9, 17, minus 9 plus 8, 17, coming out to be 0. So yes. Similarly, for E and F, you have to add 1 plus 0 plus 0 plus 0. So it is 1 only, and in this 0 plus 0 plus 0 plus 1, 1 minus 1 is 0. So yes. For F part also, you have to add 9 plus 1, 10, plus 5, 15, minus 0 plus 1, 1 plus 3, 4. So 15 minus 4 is 11. So it is coming out to be 11. So yes, it is divisible. Okay. Coming to the fifth question. Write the smallest digit and greatest digit in the blank space each of the following numbers so that the numbers formed is divisible by 3. You have to write the smallest as well as the greatest digit. Let's do it for the A. 6, 7, 2, 4. Now it is saying it is divisible by 3. You will write if dash 6, 7, 2, 4 is divisible by 3, that means it should be sum of all the digits, like then right here, then sum of all the digits should be divisible by 3 only. So we can add this dash plus 6 plus 7 plus 2 plus 4, which is coming out to be dash plus 6 plus 7, 13, plus 6 is 19. So what can be the smallest number here such that it is divisible by 3? The smallest number can be 2. It cannot be 0. It cannot be 1 because if we have 1, it will be coming 20. But it can be 2, which is giving us the number as 21 and which means that it is divisible by 3. And the greatest number that can take place here is, if I say greatest number, if we add 9 in it, it will not be 19 plus 9 is 28, which is not divisible by 3. So it will be 8. 19 plus 8 is 27, which is divisible by 3. Similarly, for the B part, you will just check smallest will be dash plus add all other numbers. 7 plus 4, 11 plus 6. 11 plus 6 is 17 plus 5, 22 plus 2, 24. So it is 24 coming out to be. So you can just add smallest number can be 0 and the greatest number will be dash plus 24. You can add 9 in it. If we add 24 plus 9, what will it be giving you? 33. So which is divisible by 3. 9 and 24 both are divisible by 3. Okay. So this is the smallest and this is the greatest. Coming to answer 6. Write a digit in blank space of each of the following numbers so that the number formed is divisible by 11. Now for divisibility rule of 11, we will see 92 dash 389. Let's x be the blank digit. So for divisibility rule by 11, we will add 9 plus x plus 8 minus 2 plus 3 plus 9. It should be 0 or the multiple of 11. Let's add these. It is 17 plus x minus 5 and 9, 14. So it is coming out to be 17 plus x minus 14, which is equal to 3 plus x, right? 3 plus x should be equals to up. Now it cannot be equal to 0. So we will take it as 11 only. We are just filling it with the smallest one. So it will be, it implies that x will be 11 minus 3, which is 7. So here it will be 7. For the B part also, you will do it like this. 8x9484. So it will be 8 plus 9 plus 8 minus x plus 4 plus 4 should be equals to 0 or 11. Let's just write for the reference. It will be 8 plus 9. Okay, 8 plus 8, 16 plus 9 is 25 minus x plus 8. It should be equals to 25 minus x minus 8, which is 25 minus 8 is 17. Minus x should be equals to 0 or 11. If we say 0, it will be 17 only, which cannot be the digit. So x will be equals to 6. Okay, so here x will be 6. Understood? We cannot take it as 0, bache, because if we take 0, it will be 17 minus 17. But x can only be digit, not a number. Coming to exercise 3.4. Answer 1. Find the common factors. For the common factors, we will first write the factors of 20, which are 1, 2, 4, 5, 10, and 20. Factors of 28, which will be 1, 2, 4, 7, 14, and 28. So the common factors are 1, 2, 4. That's it. Common factors 1, 2, and 4. This is for A part. For B part, factors of 15, 1, 3. It is not saying prime factor, so you will write all the factors 1, 3, 5, and 15. Factors of 25, 1, 5, and 25. So it is common factors are 1 and 5. For C part, factors of 35, 1, 5, 7, and 35. Factors of 50, 1, 2, 10, oh sorry, not before that, 5, 10, 25, and 50. Common factors are 1, 5. D. Factors of 56 are 1, 2. Factors of 56, it is then 4, 7, 8, 14, 28, and 56. Then factors of 120 are 1, 2, 3, 4, 5, 6, 8. Then after this 10, 12, 15, 20, 24, 30, 40, 60, and 120. Common factors are coming out to be 1, 2, 4, 8. Yes, that's it. Okay. Question 2. Find the common factors of now 3. 3 numbers are here. So factors of 4, 1, 2, and 4. Factors of 8, are 1, 2, 4, and 8. Factors of 12, 1, 2, 3, 4, 6, and 12. Okay. So common factors, 1, 2, see, now 1, 2, 4. B part, factors of 5. It is a prime number, so 1 and 5. Factors of 15, 1, 3, 5. Factors of 25, 1 and 5. So common factors, 1 and 5. Okay. Coming to the third, write first 3 common multiples. So we will write multiples of 6 are 6, 12, 18, 24, 30, 36, then 42, 48, 54, 60, 66. Then multiples of 8, 8, 16, 24, 32, 40, 48. This is, sorry, 56, 64, 72, and 80, 88. Let's see, can we find the first 3 common multiples of this? Common multiples, it is 24, then it is 48, then it is, okay, just right after this also 66 ka next multiple will be 72. So 72. So it is 24, 48 and 72. Next is 12 and 18. So multiples of 12, 12, 24, 36, 48, 60, 72. Then after this 90. Just a minute. It is 5, 6, 84, 96, 108, 120, 132. Then write the multiples of 18. 18, 36, 54, 72, 90, 108, 126. I think we will be able to find from this only. Common multiples, are coming out to be 36, 72, 108. So 36, 72, 108. First 3 common multiples. Answer 4. Write all the numbers less than 100 which are common multiples of 3 and 4. Now it will be go beyond like this. So multiples of 3. Just write all the multiples. 3. Less than 100 we have to write. So you have to write all the multiples of 3 in this. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57. Just a minute. 57, 60, 63, 66, 69, 72, 75, 78, 81, 84, 88. Not 88, sorry. 87, 90, 93, 96, 99. Similarly, multiples of 4, 4, 8, 12. Multiples of 4 will be 4, 8, 12, then 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64, 68, 72, 76, 80, 84, 88, 92, 96, and less than 100 you have to write, so you can leave it here. So you can see the common multiples are 12. Then after this we have 24. After this we have 36. After this we have 48. After this we have 60. After this we have 72. After this we have 84. And after this we have 96. These are the common multiples of 3 and 4 less than 100. Coming to the fifth question, which of the following numbers are co-prime? What are the co-prime numbers? Co-prime numbers are those numbers which has HCF as 1, means common factor. Highest common factor is 1. So, HCF of 18 and 35 you have to find. For this, we will write prime factors of 18. You can do prime factorization by this method. 2 9s are, 3 3s are, 3 1s are. So it is 2 into 3 into 3. Prime factors of 35 prime factors will be 5 7s are, 7 1s are. 5 into 7. So HCF will be HCF of 18 and 35 is coming out to be, you can see there is no common prime factor. So it will be 1. So that means they are co-prime. For B part also you will do it same. 15 and 37. Just the HCF of 15 and 37 will also be 1. So yes, these are also co-prime. When we find it by this method, prime factors of 15 will be, for HCF you will write prime factors. It will be 3 into 5. Prime factors of 37. 37 is prime number only, right? So it is 37. Prime factors of 37. Okay, so the HCF is 1. So yes, this is also. If we see the HCF of 30 and 415, it will come out to be 1. HCF will be 5. So it is not. HCF is 5. HCF of 16 and HCF of 17 and it is 68. If I found it out, because 17 is prime number here, so you can directly write it is co-prime. Whenever we are doing composite and prime number HCF, it is always be 1. So it is also the composite number. If we see 216 and 215, it will not be, because in this we can have HCF as 2 as well, right? Because, oh sorry, not 2, any other number. 215 and it is 216, right? These are the consecutive numbers, so it is also HCF is 1. If we see 81 and 16, if we do 81 and 16, the HCF will always be 1, so it is also a co-prime number. Okay. Coming to answer 6. A number is divisible by both 5 and 12. By which other numbers will that number be always divisible? There is a number which is divisible by both 5 and 12. By which other number will that number be always divisible? How will you find it out? In these types of question, you have to see whether you have to find the HCF or whether you have to find the LCM. In this, it is saying that there is a number, let the number be x, which is divisible by 5 and 12 both. And it is asking ki, by which other number will the x be divisible? Always divisible. What will we find out in this? We will find out the HCF in this. Okay. So HCF, just a minute. The way to write this question is, the number is divisible by both 5 and 12. We have to find other number by which the given number, the same number that is divisible. So we will write HCF only. So factors of 5 are 1 into 5, or you can write 1 and 5. Factors of 12 are, you can write prime factors here as well. So just write here 5. And here it will be 2 into 3 into 2. Right? So the HCF will be 1, which means they are co-prime. They are co-prime numbers. That means the given number will be divisible by, product of 5 and 12, which is equals to 60. Okay. Coming to the seventh question is saying, a number is divisible by 12. By what other numbers will that number be divisible? Okay. Now it is saying, let's take an example, 24. If 24 is divisible by 12, so you have to tell all the other factors of 12. That means you have to tell the factors of 12 itself for that matter. Okay. A number is divisible by 12. other numbers by which the given number is divisible will be given number is divisible will be the factors of these numbers, which will be 1, 2, 3, 6. It is already given that it is divisible by 12, so we will not write the 12 as factor. Okay. Okay, the next exercise we'll cover in the next video. Thank you so much.